In this class, now I am going to explain you complex numbers. So this is just like a revision class for complex numbers, and this revision class is very useful for the upcoming G-mains. Now let us see some standard applications which are related to the G-mains. Now see those applications. Here one set A is given in the set builder form as A theta belongs to open interval of 0 to 2 pi such that 1 plus 2i sin theta by 1 minus I sin theta is purely imaginary. Is purely imaginary. Then find the sum of the elements in A. Then find the sum of the elements in A. Theta belongs to 0 to 2 pi, one complete rotation. See this. This is a purely imaginary number. So then find the sum of the elements of this set A. How do we do this? See, take this expression 1 plus 2i sin theta by 1 minus I sin theta. Now multiply numerator and denominator with 1 plus I sin theta. So this is the conjugate of denominator 1 plus I sin theta. So which is equal to, now simplify this. Here A minus B into A plus B, which is equal to A square minus B square. So 1 plus sin square theta. So in the numerator 1 into 1, 1 and 1 plus I sin theta. I sin theta. Now 2I sin theta into 1. 2I sin theta plus into plus plus I into I square minus 1 minus 2 sin square theta. See, now separate the real parts and imaginary parts. See, separate the real part. In the numerator here it is 1 minus 2 sin square theta whole by 1 plus sin square theta. And here 3i sin theta by 1 plus sin square theta. They said that it is purely imaginary, which means that so this real part would become a 0. Okay, because they mentioned that given one is a purely imaginary means, you know, when do you say a complex number is known as purely imaginary? If and only if this real part is equal to 0. Hence I want to equate this one equal to 0. On equating this one equal to 0, we are going to get 1 minus 2 sin square theta by 1 plus sin square theta, which is equal to 0. Now take cross multiplication so that you will get 1 minus 2 sin square theta, which is equal to 0, and sin square theta, which is equal to 1 by 2. When you transfer square to the right side, so sin theta is equal to plus or minus 1 by root 2. Okay, students. So in the interval 0 to 2 pi, okay, for which angles of this interval? So this sine will be going to be given 1 by root 2. Means when theta is 45 degrees And when you go to the second quadrant, in the second quadrant 135, in the third quadrant 225 degrees, in the fourth quadrant 315 degrees. So at these angles, this sign will be given either plus 1 by root 2 or minus 1 by root 2. You know, sign is positive in the first and second quadrant. So at these two angles, you will get plus 1 by root 2. At these angles, this will be given minus 1 by root 2. Now, we have to get the sum of these four angles. So that is our required answer, which we have to find in this problem. Now get the sum of all of them. So if you add all of them, you will get sum of all possible angles is equal to 720 degrees. You will get 720 degrees. So in the options, actually they have given as 4 pi radians. You know, 4 into pi radians, 180 degrees. 184 is 720 degrees. Hence this option is right answer, because options were given in terms of a radian measure. Okay, I think you have got it. Now let us go to the one more application. Now see this. Let z is equal to 1 plus I. Now z1 is equal to 1 plus I z bar whole by z bar into 1 minus z plus 1 by z. Then 12 by pi radians, argument of z1 is equal to how much? See students, find it. Okay, complex number given as 1 plus I, then z1 is equal to this much, then 12 by pi radians into argument of z1. Now let us do it. See here, z1 which is equal to 1 plus I into z bar. Z bar means before imaginary part you have to change the sign. 1 minus I whole by z bar. Z bar means before I you have to change the sign. 1 minus I. See, 1 minus z. So here before this, okay, minus sign is there. Open the bracket. Minus 1 minus I plus 1 by z. Now 1 by z is how much? 1 by z, which is equal to 1 by 1 plus I. Now multiply numerator and denominator with 1 minus I. So which is equal to 1 minus I by 2 you will get. So in place of that, write that 1 minus I by 2. Now both of them cancel. Now simplify. If you simplify here, 1 plus I into 1, I. Now I into I square. Whole by. Now here what is left? Minus I. Minus I with 1. Minus I. Now minus into minus plus and I square, which becomes minus 1. Plus 1 minus I by 2. Now see here, I square which becomes minus 1, minus into minus plus. So this 1 plus 1, 2, 2 plus I whole by. So now take cross multiplication, minus 2I minus 2 plus 1 minus I. So this 2 will go into the numerator. So now z1 is equal to, so here how much do you get? So 2 2s are 4, otherwise 2 into 2 plus I, write like this. Now simplify the denominator. So here it is how much? Minus 1 minus 3i. So which is equal to 2 2s are 4 plus 2i by minus 1 minus 3i. Now rationalize it. Get the rational number in the denominator. To get the rational number in the denominator, what you have to do? See here, z1 which is equal to now 4 plus 2i by minus 1 minus 3i. Now here minus 1 plus 3i by minus 1 plus 3i. See, okay, come to the denominator. Here it is a minus b, a plus b, which is equal to a square minus b square. Minus 1 whole square, which becomes 1. Now 3a whole square. Okay, now see how much do you get? Minus 9. Minus into minus plus. Plus 9 you will get. So now go to the numerator. 4 into minus 1 minus 4. 4 3s are 12i. So this into this minus 2i. Plus into plus plus. So 2 3 is 6. 6i square, which becomes minus 6. See here, minus 10 plus 10i by 10. Now see here, minus 1 plus I. So this is Z1. We simplified that given expression. Finally you got minus 1 plus I for Z1. Now find whose argument. So this belongs to second quadrant. Whenever that theta complex number belongs to the second quadrant, you know argument of that Z1 is equal to pi minus theta. You know this. Now what is theta? Theta is equal to tan inverse of mod y by x. Now here y value is 1, x value is minus 1. 1 by minus 1, which becomes tan inverse of 1. So if you put here 1 is equal to tan 45, it is going to be 45 degrees, pi radians by 4. Now pi minus pi radians by 4, which is equal to 3 pi radians by 4. So now go to there, in place of argument of Z1, write 3 pi radians by 4. So if you write there 3 pi by 4, see what do you get? 3 pi radians by 4. Now pi radians cancel, 4 1s are 4 3s are. Now 3 3s are 9. So 9 is your required answer for this question. Now let us go to one more application. See that. See, if z is equal to x plus iy satisfies mod z minus 2 is equal to 0 and mod z minus I mod z plus 5i, which is equal to 0, then which of the following is true? See, options are given like this. First option, x plus 2y minus 4 equal to 0, and the second option, x square plus 5 x square plus y minus 4 equal to 0, and the third option, x plus 2y plus 4 equal to 0, and the fourth option, x square minus y plus 3 equal to 0. Okay, students, now let us do the solution for this question. So first take the first one. What is given? Mod z. When you transfer this one to the right side, which becomes 2. Now magnitude of z, which becomes root x square plus y square, which is equal to 2. If you take the squaring on both sides, x square plus y square equal to 4. See, transfer this one to the right side so that you will get mod z minus I, which is equal to mod z plus phi I. This is the second condition which was given in the problem. See, what is z? X plus iy minus I. So which is equal to x plus iy plus phi I. See, the next step, see, write this expression as x plus, take I common, y minus 1 into I, here also x plus y plus 5 into I. See, you know whose magnitude? So x square plus y minus 1 whole square, which is equal to root of x square plus y plus 5 whole square. Now square on both sides. If you take square on both sides, so what people do we get? If you take square on both sides, here it is going to be x square plus y minus 1 whole square. Here it is x square plus y plus y 5 whole square. So now this x square cancel. Now expand it. Y square plus 1 minus 2y. Now y square plus 25 plus 10y. Now y square also cancel. Now when you take 25 to the left side, minus 24 you will get. When it goes to the right side, 12y. Now y is equal to minus 2. Okay. So now this y value minus 2 substitute here, so that you will get, if you write here minus 2 whole square 4 cancel, respect to x value 0, x is 0, y is minus 2. Now substitute these x and y values in 4 options. I think third option is going to satisfy by x equal to 0 and y equal to minus 2. Hence third option is correct. Okay. Now let us go to one more problem. Now see this question. If z is equal to x minus iy and z power 1 by 3, which is equal to p plus iq, then find x by p plus y by q by p square plus q square, which is equal to how much? So this is the question. Now options are given like this. First option minus 2, second option minus 1, third option 2, fourth option 1. Tell me students, how do you answer to this question? See, take this one, z power 1 by 3, which is equal to p plus iq. Now cube on both sides. So it is going to be z. Now right side is going to be 1 plus iq whole cube. Now z is equal to, it is looking like a plus b whole cube. A plus b whole cube formula, a cube plus 3a square b. 3ab square. So because I you will get, so I value I square which becomes minus 1, so that here we get minus, here square will come. 3ab square. And b cube. B cube means I cube q cube. I cube you can write I square into I, which becomes minus I. Minus I q cube. Okay students, no confusion. Just simply I applied a plus b whole cube formula. You are well known to that. A cube plus 3a square b plus 3ab square plus b cube. Now write real terms in one place. P cube minus 3p q square. Plus from these two take I common. 3p square cube minus q cube into I. Now what is z? Z is equal to x minus iy. Now compare the real parts on both sides and imaginary parts on both sides. Here real part x equal to p cube minus 3p q square. And imaginary parts minus y, which is equal to, so here 3pq square minus q cube. Now from these two, so here what do we require? X by p. Now take p common from this, so that you will get p of p square minus 3q square. Now transfer p to the left side, so that you will get x by p, which is equal to p square minus 3q square. Here also send a minus 2 inside, so that you will get y is equal to q cube minus 3p square cube. Now take a q common. If you take a q common, so here it is going to be q square minus 3p square. Now find this value. So substitute x by p value in the place of x by p there. So here p square minus 3q square plus y by q. So when you transfer q to the left side, y by q, there what, how much is left? Q square minus 3p square whole by p square plus q square. Now here p square minus 3p square going to be minus 2p square. So here minus 3q square plus q square minus 2q square whole by p square plus q square. From these two what do you get? Minus 2 as common inside, p square plus q square whole by p square plus q square. So both of them cancel, which is equal to minus 2. So minus 2 is your required answer. See, now let us go to one more application. See that. See, Z is a one complex number of unit modulus and argument of theta, then argument of 1 plus z by 1 plus z bar. Find argument of 1 plus z by 1 plus z bar, where z is a complex number of unit modulus, means mod z is equal to 1 given, and whose argument is theta given. then what is the argument of this? So options are given like this: minus theta, second one pi by 2 minus theta, third one theta, fourth one pi minus theta. Okay, see, complex number with unit modulus whose magnitude is 1 and whose argument is theta is given. Then find the argument of 1 plus z by 1 plus z bar. Okay students, then how do you do this question? Tell me. So you know students, mod z into mod z bar, both magnitudes are same. You know, mod z is equal to mod z bar. Hence, whose product is also would be given 1. Then in place of mod z bar, what do you write? In place of actually, see, this is correct. And also you can find z into z bar is also equal to 1. Yes or no students? If magnitude of a complex number is 1, then you can write z into z bar is equal to 1. Okay? See, actually z into z bar, you know, you get, if you take x equal to, z is equal to x plus iy, then z bar will be x minus iy. If you take whose product, x square plus y square equal to 1. Okay? Alright. Now go to this. No confusion here. Whenever magnitude of a complex number is 1, in such case you can write z into z bar equal to 1. Because if you apply magnitude on both sides, you get this step. Both magnitudes are equal to 1 only. Hence, so your argument of 1 plus z by, in place of z bar, so send it to the right side. 1 by z you can write. See, argument of, this will go into the numerator in the next step. 1 plus z by 1 plus z into z. So both of them cancel. Now argument of z value is theta only, which was given in the problem. After simplifying this, again you get argument of z. So this was given in the problem itself as theta. Now write that theta here. So third option is a required answer for this question. Next. See this question. This is easy. 1 by I power 2020 plus 2 by I power 2021 plus 3 by I power 2022 plus 4 by I power 2023. Now simplify this. So shall I give you options? Now options are given as 3 root 2, 4 into root 2, 2 root 2, root 2. See students, here I power 2020 given. So if you simplify I power 2020, so you can write I square whole power 1010. I square value minus 1. Minus 1 whole power even number which becomes 1. So here In place of this, 1 by 1 you have to write. Okay. Now go to the next one. Now I power 2021 is given. This you have to write I power 2020 into I power 1. So this we have prepared here. You got as 1. If you write here 1, it is going to be 2 by I. Now see what is given there, 2022, which is equal to 2020 into I square you can write. So this is going to be 1 and I square, which is equal to minus 1. So you will get minus 3. Now go to the last one. I power 2023. Now it has to be written 2020 into I cube. So this is going to be 1. I cube can be written as I square into I, which is equal to minus I. So minus 4 by I. Now see, get the sum of these two, minus 2. Get the sum of these two, minus 2 by I. So multiply numerator and denominator with I, so that you will get minus 2. So I square is equal to minus 1. Minus into minus plus 2I. Now find their magnitude. 4 plus 4, root 8. Root 8 can be written as 2 into 2 into 2. So from these two take 2 common. 2 root 2 is a 2 root 2 is your required answer. Okay students, I hope you have understood this. Okay, in my next class of this complex numbers, I am going to explain you some more models which helps you in upcoming G-Mains. So I am requesting you to subscribe my channel and share it to your friends. Thank you one and all.